Okay, so for this one, we have to find the mesh currents, and then we see that this circuit has a mutual inductance. So what we're gonna do is write a dependent voltage source, and we're gonna have the positive face it in the direction of the red dot, negative in the other way, and same goes for here. Positive facing the red dot, and negative facing the other way. Now so pretty much this is being induced by the current passing through here. So um oh sorry, it's being induced by I2. So the current is passing like this way. So its value is going to be the mutual inductance, which is J2 times I2, and we see I2 is entering the negative port first, so it'll be minus I2. And then for this one, it's going to be UVC. It's pretty much the current passing through here, and it's pretty much I1 minus I2, because I1 is entering the positive part, and then I2 is entering the negative part. So it'll be J2 I1 minus I2. So I'm just going to redraw the circuit. So 100 phasor 0 is pretty much just 100. There we go. And then I2 here. And then 2J I1 minus I2. Okay, and we pretty much can just do a mesh analysis to solve for I1 and I2. So it's pretty much minus 100 plus 4I1 minus 3J I1 plus 6J I1 minus I2 minus 2J I2. And so this is mesh 1. This simplifies to minus 100 plus 4I1 minus 3JI1 plus 6JI1 minus 6JI2 minus 2JI2. And when we collect like terms, we should get minus 100 plus 4 plus 3JI1 minus 8JI2. Now for mesh 2, it's where should we start? Let's start from so let's start from here. So minus 2JI2 plus 6JI2 minus I1. Wait a whole little bit. Oh no, sorry. It's minus 2JI2. Sorry. Because since we're entering from the negative port, we have to add a minus sign, and then we add the entire value of this. So if this minus wasn't there, it would just be minus 2JI2. But since there's a minus sign here, it's going to be minus 2JI2. So these minuses cancel each other out. Then minus 2JI1 minus I2 because of the other source, plus 8JI2 plus 5I2. Okay, and then this simplifies to 2JI2 plus 6JI2 minus 6JI1 minus 2JI1 plus 2JI2 plus 8JI2 plus 5I2. Okay, and then this simplifies to, after you collect all like terms, minus 8j I1 plus 18j plus 5 I2, and that's equal to 0. So let's isolate for I1. So I1 is 18j plus 5 all over 8j times I2. And we're just going to plug all of that into our other formula. So it's going to be minus 100 plus 4 plus 3j times 18j plus 5 all over 8j times I2 minus 8j times I2. Let's get everything in phasor format. So this one, so minus 100 plus 4 plus 3j, that's 5 phasor 36.86 degrees times, so 18, so pretty much we have 18j plus 5 all over 8j. So obviously break that up, so it's 18 over 8. The j's cancel out, then 5 over 8j, and then you just bring the j to the top, so this turns into minus. The phasor for that should be, give me a sec, 2.335 phasor minus 15.52, and this is I2 minus 8j I2. Okay, now we can combine these two phasors. So minus 100 plus, so 5 times 2.335, that's 11.675 phasor 36.86 minus 15.52, that's 21.34 degrees times I2 minus 8j I2. Now we have to incorporate this into our phasor. So we'll break up our phasor up. So 11.675 cos of 21.34, that's 10.87, and then sine of 21.34, that's 4.248j, and because that's on the imaginary plane, minus 8j I2. So obviously we just combine, we just combine these two. So it's minus 100. Hold on, let me quickly calculate this. Okay, so 10.87 minus 3.752j times I2. Let's bring the 100 to the other side. So this is, so I2 is pretty much 100 all over this value. This value in phasor format is 11.5 phasor minus 19.043, and 100 is the same thing as 100 phasor 0. So this is just 8.69 phasor 0 minus 19.043. That's positive 19.043. This is in amperes. This is our first answer for I2. And then I1. I1 is equal to this. Okay, so 18j plus 5 over 10j. That's pretty much 18 over 8 minus 5 over 8j times I2, which is 8.69 phasor 19.043. And recall the phasor for this was this right here. So 2.335 phasor minus 15.52 times 18.69 phasor 19.043 times the two values, that's 20.3, and add the phasors, that's 3.5 amps. So these are your answers.